Okay, so we're going to finish off our implementation of the A-star algorithm that we started in class. We're actually going to restart from the beginning, and I just want to make sure that everyone's on the same page about how this is implemented. So first, open up an IDE like Mu and make sure you save a empty document as AI pathfinding. And we're going to first start with importing a few modules. We're going to import Pygame. As you guys know, this is just the GUI for game development. So this is for graphical user interface of our algorithm here. We're going to import heap_q, which I'll explain in a bit what that does. But basically, you can think of it right now as a smart to-do list that always gives us the most urgent task. And it helps us decide which square to visit next on our map and to get to our goal faster. All right. Let's put a note here. This helps us with sorting the nodes we'll explore. Okay. And then we're going to import random, and we've used that many times before as well. We're going to use this to generate random numbers, which we'll use in our A-star pathfinding demo here. Okay. All right. You can save this. And really quickly, I want to talk a little bit about heap_q a little more. So a heap is another kind of data structure. You guys have learned about lists and dictionaries and tuples and sets. A heap is a way of representing a tree in memory. So there's two kinds of heaps. There's a min heap and a max heap. We're going to actually be using a min heap in our program. A min heap is really useful for implementing something called a priority queue, so that items that have higher priority are always sorted at the top of our tree structure. You can see here this list of items with a 2 at the top is the highest priority. This is how it's actually stored in memory. 2, 3, 6, with 3 and 6 being the branches off of 2, and then 8, 10 as the branches off of 3, and 15, 18 is the branches off of 6, and then 20, 25 is the branches off of 8. So you can see it again here, if that was difficult to follow, with another min heap here. So 9 is at the top of our tree, or the root of our tree rather. We got 12 and 20. So we left and then right always. So 12, 20 in our actual list in memory. And then again, we add a 14, it's going to go left again. And then you add a 21, it'll go right, okay, to add the children to 12. All right, I'm going to actually show you how the heap_q module works in Python. So I'm going to go back over to Python and open up REPL, or if you're using Dony, you can open up the shell, or you can do that in Visual Studio Code as well. So I'm going to import heap_q here. And then I'm also going to create an empty list that I'm going to call my heap. Okay. Now that we have the empty list, now what I'm going to do is push onto this heap. So I'm going to say heap_q, heap push, to the name of the heap that I'm going to push onto, and then I'm going to push something onto it. So I'm going to push on a 25. Okay. And let's say heap 20, 15, then 10, and then a 5. Okay. All right. So if we look at my heap, here, our root is 5 because this is a min heap. It has 2 branches, 10 and 20. And then 10 has 2 branches, 25 and 15. Now, in general, it doesn't really matter what the branches are. The heap always makes sure that the smallest element is at the top. So you notice that 15 is down here. But if I pop off of the heap, if I say heap_q, heap pop, and then I say my heap, it'll pop off the 5, it'll pop off the 10, it'll pop off the 15, even though 15 was the branch off of the 10 before, okay? Even though it was down there, okay? Now it'll pop off and actually before I pop it off, let me show you what the heap looks like now. It has 20 and it has 1 branch, okay? So that's how we're going to keep track of the priority of what cell to look at when we're working on our algorithm, okay? Just wanted to make sure you guys understood that before we actually delve into this, because we'll be using this data structure quite a bit in our algorithm. All right, so now that we have our imported modules, now we're going to initialize Pygame. So that's just like turning it on so that it will take commands. So initialize Pygame. You're going to say pygame.net. All right. Now we're going to set some constants for our game. So we're going to set a window size, and then we're going to set a grid size for how many squares to fit on our game window. And then the cell size basically is going to be the size of the squares. So these are constants. As I said, window size is going to be a tuple with 500, 500. Our grid size is going to be 10 for right now. You can change that to something higher when you want to play with it, but we're going to start with 10. And our cell size is going to be our window size divided by our grid size. Okay. Remember, 2 slashes does division without a decimal point. Okay. So now that we have this, we're going to define some colors for our game. So we're going to have a red, green, blue, and white and black. Okay. As you guys remember, we define colors by using RGB values, red, green, blue. Let's do that. Let's start with white, and then black, and then green, and then red, and then blue, and then yellow. Okay, so let's define yellow here. We're going to say it's 255. Yellow is red and green together, so we have 255 for all the way on again, and then 0. Okay, so for blue, we have 0, 0, and 255. Okay, for red, we're going to have, and let me put this up here so it's clear. This is red, this is the green color, and this is the blue color in the tuples that we're creating here. 255, 0, 0 for red, and then green, it's going to be 0, 255, and then 0. And black will be 0. You got a comma there. 0 and 0. And white will be 255, 255, 255. Okay. All right. Now that we have our colors, the next thing we need to do is initialize our screen. Going to initialize screen, basically setting the stage for our game. We're going to say screen is equal to pygame.display.setMode. And we will send over to that method our window size, the tuple that we have in that, and the window size constant. Next, we have pygame.display set caption. This will be the title of our window. So A star pathfinding. Okay. All right. As you guys know, at the end of all of our Pygame programs, at the end of our game loops, we're going to have pygame.quit. That will make sure that is always at the bottom of our program. At this point, we can actually run it to make sure that the window is going to be created properly. So I'm going to run it here. Okay, so I do have an error somewhere. Yes, I defined our cell sizing correctly. So because this is a tuple, what I need is the first item in the tuple. So I need to get the first item so I can divide by 500 here. Okay, so now I'm going to write it, and so now I'm going to run it, and this is what we get. We get a Pygame window. Okay, so I'm going to close this and stop that. And next, what we want to do is actually define our game loop. Okay, we're going to say here, this is, as you guys know, this will run continuously as our game is running. This is our main loop, and we're going to say running equals true, and then we're going to say while running. Okay, all right, so first inside of our game loop, what we want to do is set up some event handlers. Our program's going to wait to see if a mouse click or keyboard is pressed, etc., and reacts accordingly. For our game, we're going to mainly be looking at two things. First, we're going to look at if the user closes the window to stop the game, and if the user presses any key to start our algorithm running. Okay, we're going to say here, let me make a little space and bring this up a little bit and actually make this a little bit larger. I'm going to say for event.get, we are going to say running equals, actually we're going to say, we're going to say ftype equals pygame.quit. Then we're going to say running equals false, which will stop our loop. Also need to check for button presses. So we're going to say fEvent.type equals, and this should be double equals for equals instead of singles, equal sign, which is assignment, but then pygame.keydown. Okay, so now that keydown. All right, so now what we are going to do is actually put all our code inside of this if statement. So all of our code is actually going to run inside of our if statement for our implementation here. At first, what we want to do is once the key is pressed, we want to randomly generate a start and ending point, or start and a goal for our pathfinding algorithm to work on. So inside of our grid, our 10 by 10 grid. All right, so this ensures that each time we press a key, we'll get a new pathfinding challenge. So to do that, we want to have a randomized start. We're going to randomize start and end points. I'm going to say start, and it's going to be equal to, and these will be basically XY coordinates, or yeah, these will be coordinates on the grid. So we're going to say a rand range, and we're going to go from 0 to our grid size. And remember that rand range works the same way that range does, so it's going to go all the way up to our grid size, but it's not going to include the last number there. So it's going to go all the way up to 10, but not include 10. So our grid will be 10 by 10, but it'll start at 0. So we're going to say random.rand range, and we're going to do it again for the other coordinate. Okay. All right. And now, so that we're going to store that inside of a tuple. We're going to do the same thing for our goal here, where we want to go. Again, another tuple, and the first item in our tuple is going to be again random rand range, where we want 0, grid size, and second item in our is going to be random rand range 0, grid size. Okay, so we'll get two tuples with two random numbers between 0 and 9 for our coordinates on our grid. Okay, all right, now we need to make sure that our start and our goal isn't the same. If it is, we need to reset it. So here we're going to make sure start and goal are not the same. All right, because what will be the point there? So they'll be found very quickly. So while start is equal to goal, we're going to regenerate goal. So this might not run at all, but f when we generate this and we start and we generate the goal, random things can happen and they could be exactly the same. If that's this case, we'll go into this while loop and it'll keep going until this is not true, when the start isn't the goal, and it'll keep generating new random goals. Okay? So next, what we want to do is set up our grid, okay? And we're going to actually create a function later on to do that. So right now, what we're just going to do is actually call the function that we're going to create later on. We're going to say set grid, and we're going to say start. We're going to send it's the start and the goal, and it'll set up our grid for our pathfinding algorithm. So it'll make the screen black. It'll basically just like cleaning off a chalkboard, and so we can write new stuff on it. It'll draw the fresh grid, and it takes two arguments. Like I said, it takes our new start and our new end. Every time we press a button, we will get new start and new end, okay? And then it will also place the start and the end on our grid in red and blue, okay? Next, in our loop, we want to actually call our A-star algorithm. Okay, the algorithm will return came from, so we can actually use where it came from once it's finished running to trace its steps back to the start once it's reached the goal. Okay, we're going to call the algorithm. Again, this is something we're going to write later on. Make sure I put a note here, clear the screen, set the stage. Okay, now we're going to run a star algorithm and draw path. Okay, so first we're going to call the algorithm and have it save it turn into a variable. So we're going to say came from, it's going to be equal to a star search algorithm, and then we're going to give it a start argument and a goal argument. Okay, so when we create that function later on, those are the two parameters that we'll need. Then we're going to set current to goal, okay, so that we can backtrack from where the A-star algorithm found the goal, okay? So now we need to actually draw the path from the goal back to the start, and we're going to do that with a while loop here. So we're going to say while true, so this will loop forever until we break out of it. So we're going to say while true, and we're going to say pygame not draw, right? And then we're going to draw on the screen that we created earlier. We're going to draw blue, and then we're going to use the current, the first coordinate, times the cell size. For our rectangle coordinates, remember the way that rectangles are created, we need x1 and y1 and then x2, y2 positions. All right, so current 0 is going to be multiplied by the cell size. Make this a little bit smaller because it's going to go over a little bit. And then we need cell size. All right, we need to do pygame display update. So we'll actually update the screen and time delay, because this is going to run so fast that you won't be able to see it if we don't put a little bit of a delay here. Also, what we want to do, once we've drawn the square, we want to say update the current to came from current. This will make sense a little bit later on, but came from is actually a dictionary that's being sent back to us. So we're referencing the next thing in our dictionary so that we can go back to where it came from. So where the square or the cell that it came from, so we can trace our path back to the start. Okay, but we need a way to break out of this. So I'm going to say f current equals start. Then we are going to actually do this all one more time so that we draw blue on our start. And then we are going to break out of this loop. Okay, now at the bottom of this while loop, after the for loop has run, we're going to do a pygame.display update to make sure everything updates properly. Okay, and then at the very end, like I said, we have our pygame.quit. All right, so now what we need to do is actually create our functions. So we need to create our A-star search function, and we need to create our set grid function. So let's start with our